Welcome back. Today we're going to continue with our Simpson 360 meter, and we're going to take a look at making up the charging circuit for it. Hopefully everything will work out here. So I did a little research, and it looks like the charging circuit works off of 120 volt, and it has an 8 volt DC 350 milliamp power supply. Now it uses tip and sleeve on a tip ring sleeve jack. Now that's a standard 1/4 inch stereo jack, and you can see here that we go through the regulator and the converter and all of that other stuff. So what we're going to do is we're going to take a random 8 volt 350 milliamp transformer that we have here. This is UL listed, so I'm not as afraid as I am with normal Chinesium stuff. And I think what I'm going to do is I might just do the old snipperoni here, and we are going to install, wait for it, we're going to install one of these, a stereo 1/4 inch jack, and we'll solder that on, and that will be our connection. So to do this, we're going to try out a 3D printed, kind of homemade soldering iron that I got off of typical websites that you get things. And this thing here, you basically turn it on, and we will set our temperature, set for 608 degrees Fahrenheit. We'll just let that flash up in the background here. And let's get our jack apart. Let's see how this one goes together. They're all a little different. This one pulls apart, so it's got pins in it here, I see, that make it go together. So here is our tip connection, our ring connection, and our sleeve. So tip, ring, sleeve. There's also a 4-conductor one that is tip, ring, there'd be another collar here, sleeve, and ground. So, and then there's also a 2-conductor version that's just tip and sleeve. This being the stereo format, or commonly used in the telephone industry. Tip, ring, sleeve. So what we'll do is we will solder a connection on here, on our tip, and the other one here on our sleeve. Now we can prove this out with our meter, actually. Let me go get some leads, and we can use this thing to test it out. Alright, so we have our meter hooked up, and you can see here when we touch the leads together, we get about 0. And you'll also notice our analog meter on here, right up here, moves as well. So our meter seems to be working properly. So let's take our sleeve connection here and verify it. There we go. So I'm just touching this part here. You can see there's a hole there for soldering, and this should be our tip. We'll hold that on there, and we'll hold that on there. You can see that's the tip. And then the one in the middle here is our ring. So let's just hold that on the middle, and we'll go to the one in the middle. There we go. Right in. I know the digits are digital or blurry in the background, but you get the idea. So that tests out the way it should. And if we recall in our diagram that we want to have our connection on tip and sleeve, so it's positive to the tip, negative to the sleeve. So the next thing we need to do is cut the end off of this and meter the 2 wires to see which is positive and which is negative. So to do our electrical work here today, we're going to use a snap-on stripper. I honestly didn't think I was going to like this as much as I have. I've been playing around with this. I thought it was going to be a lot cheaper made. I'm not going to do a review on it here, but you can see it's much thicker than your normal ones, and the handles are kind of forged. So It's actually not a bad tool. I kind of enjoy using it. So what we're going to do here is we're going to cut this off. I'm going to leave it long enough that, you know, the old pack rat can go ahead and use this here for something later if so wanted. And we're going to just take this and pull the zip cord apart. And then we're going to take our stripper, which hopefully goes small enough. Probably not. Nope, doesn't go quite small enough, but we'll get it. Okay, so now that we've got that stripped, what we're going to do is we're going to move this to DC volts, 20 volts, because we are 8 volts. We're not at the 2 volt range, we're at the 20 volt range. And we're DC, 8 volts. Let's see. We have our leads separate from each other. We don't want them touching. We're going to plug in our transformer right there. And we're going to take our meter leads that I've already lost. And I think on this cord, a lot of times the white mark is your positive and the all black is your negative, and I am wrong. So let's go here. Solid is the black. 14 volts. Well, that's not really good. That's way higher voltage than we want to see. So that transformer might not be one we want to use. Now, is that because it's not loaded? That's very interesting. Okay, so I've never actually metered one of these wall wart transformers before, so what I did here, I think we may still be in the running, and I think the way they work is they're kind of variable voltage. So if I hook up a load to this, which is this light, bear with me, we gotta hold everything here. So we have our positive and our negative, and that is the, you can see the voltage drastically sags down to 10.5 volts, and that is our it goes from 14 to 10.5. And so I think what they do is they have, it's 8 volts at 350 milliamps. So I think we have the right one here. I also have a 9 volt one that I'm not going to cut the end off of preemptively, and we're going to meter that and see if it's actually 9 volts, or we're going to see if it's higher, because I don't know. So here's our 9 volt one, that's 350 milliamps. I initially bought this because from the photos that I found of the Simpson charger, it looked like it said 9 volts. Now, if we meter this and it's actually 9 volts, I may still use the 9 volt one because the voltage is lower. So here we go. We got a piece of wire jammed in the end of this to make connection, and tip and sleeve. The 9 volt one is also sitting at 14.4 volts. So that tells me that these things are a nominal voltage at the current rating that they have. So we're going to continue on with the 8 volt one and not be scared. Alright, so remembering that white stripe on our cable, I don't know if you can see it there. It's this cable here. That is our negative. What I want to do is shove that through the hole here for our negative and solder it. So that's going to go through here like that. We'll fold that over just like so. I think I'm going to pull that away. We're going to clamp that in our vise just like this. And we're going to take our soldering iron and a little bit of solder. Now, I have not used a chisel tip on this thing before. I thought I'd give it a go here. My thought was we could put it on an angle like this. Heat it up. I don't know, it's not flowing well. Let's crank the heat up a little bit more on this thing. Now you'll note that I just desoldered that, and don't do what Donnie Don't does and forget to put your collar on. That's a classic chestnut. So now that our collar is slid over the wire, we'll resolder that. I turned the fan off. We'll see if we get a better solder joint this time. I'm kind of curious anyway. I wasn't happy with how cold that looked. So I think what we'll do is they also both need to be different lengths. So we're going to do the tip first, and then we'll shorten up the ring. So flip this over, jam this in like I said before, and all we want to do is push those wires up through there. Give that something to hold on to, just like that. And now, you don't want to overheat things. That's why I was hoping this chisel tip would work better, but it might not. You just want to get some heat in your workpiece, and you want everything to just flow out. Which it's not really doing with this tip. So I may change tips here. There we go. Get something to flow in here. That's just awful. Alright, so since we figured out that this chisel tip's largely useless, we're going to put on a regular pointed tip here. And really this style gun, or iron, all you do is pull this out. I believe it's the whole heating element is in that. And you slide in your other one, just like that. Naturally, after everything's cooled off, and you tighten your nut here, we'll turn our soldering iron back on, and it says it's heating up. Now it could be I have bad solder also. This is, you know, genuine horrible Chinese solder. So we're going to change two things, because that's what a practical person does when they don't know, and then you don't know what you did to fix the problem. I don't know if I'm going to, though, because I don't see my other solder. So I guess we'll find out if it's just crappy solder. Alright, let's see if we can melt solder. We can. Let's get some heat on this. There just may not be adequate flux in this solder to give us that nice appearance of a good joint. Because it looks nice when you start, but when it cools, it turns that color that's just not ideal. Anyway, we're going to call that good. Alright, so let's get this in our clamp, or vise here. Not squeezing this hard at all, just enough to hold it. Let's get some heat on this and see if we can flow some of this crappy Chinese solder in here. I really need to get some better solder. I feel like I'm about to overheat this thing. And now together. Well, this is probably the worst solder job ever, but we'll see if it works. Okay, so here's what I was talking about. You don't want to overheat things. If we can get the camera to focus on where we are. You can see that insulation starting to get a little bit melty. If I would have overheated that a whole lot more, we could have shorted the two conductors together. So that's kind of what I'm talking about. You don't want to do. But I think we're okay here. We'll meter it, make sure we're good before we get crazy here. So this here just goes over top. It pins on there, just like that. And then after you've remembered to put your collar on, that all slides up. Slides up here. That's just an insulated collar there. I guess what I should maybe do is, yeah, what the heck. We'll squeeze these together and try and act like a little bit of a strain relief. We'll just use our strippers here. Squeeze these together like this. Create a little bit of a strain relief there. Nothing overly complex. Slide our safety sleeve over, and then we put our retaining nut on, just like that. So now that is together. Alright, so what we want to do is we want to meter this to make sure, let's go back over to here, resistance, turn this on. We want to meter this to make sure we didn't short it out with that crappy solder. And what we should get, sleeve is the ground, tip is our positive. What we should get is some form of resistance. And we're not. Let me go here. We're not getting nothing. It's just open. Okay. So I guess that's good. It's just open. Let's just double check here. We are getting resistance here. I thought I would get resistance here. Guess not. Okay, so let's go to our voltage again. And let's plug this thing in. 120. Let's check our voltage. So we should have that 14 volts we saw before from sleeve to tip. And we do, 14.3 volts. That's the same voltage we had before. So what we should be able to do now is turn this off. We'll remove our leads. And this thing has in the back a 1/4 inch jack. Now what I want to do is I would like to meter the charging voltage if I can. I don't know if I can easily or not. Yeah, we might be able to. We might be able to get the gist of it. So now we're going to enter in the Fluke 87. Okay, so we got our Fluke 87 out, and all I really want to do here is get a baseline. So here's a positive and a negative, and I know this isn't the best representation, but we have about 2.56 volts DC. Now what we should be able to do is, this is a 1/4 inch jack here. Make sure this is off. It is off. Let's plug this in. Okay, that's plugged in. Didn't feel like it went in perfectly, but you never know. And let's turn this on. Okay, so we got our charging light. That's a good sign. Now let's see what our voltage is now that we're supposedly charging. So we had 2.56 volts. Let me get the meter leads and everything in the way of the meter. Yeah, that's really not exponentially higher. So I don't know if this is working. No, 2.583. So that's working. It's 8.4. It looks like it is working. It's climbing. Let me let this sit for a little bit and we'll come back. Alright, we're back. Things are happening. So if you remember, we started at 2.56. Let me jam that on the positive. And we are at 2.603 and climbing. So we appear to be charging, which is good. I do not know if this thing will eventually turn itself off or if it continues to charge. Let me do a little digging to see if I can figure out how the operation of this thing works. It very well could turn itself off. I don't know. Okay, I should have done this before, but I just looked up how we do a test on the battery voltage. So this meter actually has a built-in function to test the battery voltage. You plug in one of your probe leads to the positive, and you plug the other into the battery test lead, and you simply touch the two together. And we get 5.05 volts. Now, you're not supposed to operate this meter if you are down below 4.7 volts. So what I'm going to do is we're going to undo this stuff and we're going to put the charger back on. It appears as though it takes up to 15 hours to charge this, so I'm not going to leave it unattended and charging, but we're going to go back to off position and we're going to plug our jack back in, and we are going to turn this to battery charge only, and we're going to let that charge, and we'll just intermittently check that voltage and see if it comes up. So 5.06, we'll come back in a bit and see if it comes up. And we're back. So a little bit of time has passed. We've had this on charge a little bit. I believe the floating voltage for this should be like 5.7-ish, because NiCad batteries, their fully charged state should be like 1.44 volts, I think it was. So like 5.76 should be fully charged, and they say that 4.7 should be the fully discharged rate, that you shouldn't use this meter below 4.7 volts, which I think is like 1.1 some volts per cell, so that's down there. But let's see where we're at now that we've been charging for a while. 5.08, it's a slow increase. It was 5.06. We're just slowly increasing. It's a very low current. I can say that this is not really getting warm at all. It's slightly warm, but it's not like it's getting hot. So it's just continuing to go on here. This is going to be a slow process, I think, which is okay. You don't want to throw too much heat at these things, because that's when things can kind of go bad. So let's get this plugged back in and turn on our charger. We'll be back if we have anything to report. I'm curious to see if the battery charge light will go out when it reaches its final voltage. Time will tell. So curiosity got the better of me. I was reading that with it hooked up, you could still use the meter. So I got curious and I thought, I wonder if it shows what the charging voltage is. And sure enough, there we go. We got our two leads touched together. We are charging at 5.15 volts. I'm assuming this will continue to climb as the voltage in the cells increases, but that does confirm that we are indeed charging. We've proven that before, but it'll be interesting to see, to keep monitoring that. I guess I could leave that hooked up. It'll be interesting to keep monitoring that as we go up through here. So to test the voltage like I'm doing, you hook one lead up to the positive and one to the battery test. And we're back. So if you notice, our charger now says Simpson 360-2 charger on it. If you're anything like me, you have a bunch of these things around the shop and you never know which one does what. This one's going to be somewhat distinctive because it has the audio jack style connector on it, which I really dislike. I don't like using other style components. That jack style is large and widely used for audio. These are largely used for audio. I do not like putting power over things that are normally used for audio, because people plug things in their wrong stuff and then things get fried. But anyway, that's what they used, so that's what we used. Let's do a check-in here and see where we're at. So we go to DC volts, 20 volt scale, battery test, put our two leads together, 5.23, she's climbing. So it's definitely working. Our charger is not hot. You can feel some warmth when you touch it, but it's not bad. Let's go back to charge there. Our light still comes on. We'll just keep her going. Alright, we're going to do a check-in here. Let's see where we're at. Charging voltage. We are up to 5.3 charging voltage, so we're getting there. Remember, I think we're going to want to be somewhere around 5.76, so we'll just let it keep charging. Alright, I thought we'd do a check-in. It's been a little while. Still had this thing charging kind of in the background, doing some other stuff. Let's check in on it. 5.56, so it's still going up. If I'm right, we should get up to 5.7 or so, and then I'm curious to see if the charger will go off, so we'll just keep it going. Okay, we have an update. I believe we are at where it's going to be. The charger's transformer has kind of cooled off a little bit, and we do not get past 5.59 volts. So I believe 5.59 is fully charged. Let me disconnect the charger. There we go. And let's see what the actual voltage of the cells is floating. $5.47. Sure, I get on board with that. So there we go. That's a full charge on the Simpson 360. I think we got everything working on this. The voltage, we might play around with a little bit more, because you saw when we did the test originally that when you're at the 200 volt range and you're kind of reading around 21 volts or so, it's not very accurate. So there's still some stuff that's not exactly right on. I'm still working out. Maybe I'll get some stuff that we can use to test the resistance values as well as possibly the current values. So we'll see. I might be able to come up with some stuff, and we could test this stuff a little bit further. But for now, this is as far as I can take it. We have a meter that's working reasonably well. And I think we're going to continue to use it and compare it with the Fluke 87 and see how it gets. So I hope you enjoyed this video. We kind of made the charger out of parts that we got. It's just an 8 volt transformer here that's 350 milliamp. The 350 milliamp is important because you don't want to throw more current at this thing than it can handle. And then this is just a normal 1/4 inch stereo jack. So those two things together will get you charging. So hope you enjoyed. As always, thanks for watching and have a great day.